Here's the second version of my formula. We have an equation of hyperbola that is still centered at 0, 0. And I can tell that because we have y squared and x squared. We have nothing in parentheses. We have no HK. And then now my transverse axis is along the y. And y, because my y is first. Notice a squared and b squared haven't changed. Now we're looking at where is that y or x. So when y squared is first, or more specifically, when it is positive, my transverse axis is along the y. So you can see all of my important points here, my two foci, my two vertices, and that center are all on that y-axis. And now these are going to open up and down. So these are the same, except now my value for A is in my y value, and my C is in my y value, not my x. This formula doesn't change, but this one does. If I can find, here it is. When my transverse axis is along the x, it's b over a. When my transverse axis is along the y, it's a over b. So that slope is going to change. So we have to be careful and make sure we use the right version for that. But this formula didn't change. That's going to be the same for all hyperbolas. So let's get into it. Analyze the equation. 9y squared minus 4x squared equals, I'm going to put 36 right here because that bothers me. And that is find the center, transverse, vertices, foci, and asymptotes. So first thing I'm going to do is rewrite this down here. And this is not in the correct form. We always want these to equal 1. The only one that doesn't equal 1 so far is circles. So to get this to be 1, I need to divide this over. And so now divide. If you put in your calculator 9 divided by 36, you get 0.25. Now that's a pretty common fraction, so we should know that that's 1/4. But in case it wasn't common, I would need to go to math and change it to a fraction, and we get 1/4. So now we have y squared over 4 minus, do the same thing here, 4 divided by 36. We get 0.1 repeating. That's not as common of 1. So if I go to math, change that to a fraction, we get 1/9. So we've got x squared over 9 and now equals 1. A lot of times, this isn't going to happen probably in the real world, right? But in our world, these will always switch. So the 9 now is under the x, the 4 is now under the y. Okay, so now I'm going to use this to get all of my information. So I can go ahead and find the center and the transverse axis. I typically like starting with the transverse, but it asks for center first. So that's not hard. Because these are x squared and y squared, no h, no k, nothing in parentheses. Our center is at 0, 0. And then where is my transverse axis? Okay, if you said x-axis, you're thinking in your old ways like ellipse. It doesn't matter that this bigger number is under the x. What is first, what is positive, is what we look at for our transverse. So our transverse axis is the y-axis. Okay, so there's 2 of my 5 questions. So we have found center and transverse axis. Now I need vertices, foci, and asymptote, and I need my A, B, and C for that. Okay, what does A equal? Okay, it is not 9. A here is always first. So my A squared is 4. So, oops, I didn't mean to write that but whatever. So A is 2. We can do it that way. That's fine. So then this is my B squared. So then B is 3. So I have enough information to give my vertice and my asymptotes, but not for my foci. I need C for that. So if I come over here, we have B squared equals C squared minus A squared. B squared's 9. Don't know C squared, and A squared's 4. Add that over, and we get 13 equals C squared. Take the square root, and square root of 13 is a prime number, so that will stay square root 13. Now I'm going to need that decimal for whenever I graph. So the square root of 13 is about 3.6. All right, so now that I have A, B, and C, we can answer the rest of this. I need my vertices. Vertices are 0, comma, plus or minus A. So we have 0, comma, -2 and 0, comma, 2. I need my foci, which are 0, comma, plus or minus C. So 0, comma, in my math lab, you're gonna have to use that square root 13, the negative square root 13, and 0, comma, square root 13. And then asymptotes. We have y equals plus or minus. This one is A over B. So my A is 2, my B is 3. And then X. So there is the rest of the questions that it is asking. So once we find all of that, now it wants us to graph. So I'm going to plot my center in red. My vertice is 2, and because my transverse axis is the y, all of these points need to be on that y. So I'll go up 2 and label that as V, and go down 2 and label that as V. My 3 helps me make the box, so I'm going to go 3 units this way and 3 units this way. And then my C is about 3.6. So 2, 3, and about a half for my F, and 2, 3, and a half for my other F. Okay, so now let's make the box. We make the box between our B's and our V's. So I do a little box. And we can draw in our asymptotes. We'll go corner to corner through the center. And I make big dashed lines for my asymptote. And then go the other diagonal. And then we can make our graphs. I'm going to go back to blue and connect from our vertices and start hugging. Need more room here. Hugging those asymptotes. So the only part of this graph are those blue lines. And you can see this one's very wide this time. And if again, we're looking at that asymptote, we have rise over run. I am running, or I'm rising 2, and I am running 3. There's my positive slope. I am rising 2, and I'm running a -3. So there's your negative slope for those asymptotes. Let's do one more example here. Oh, two more examples. Find the equation of the hyperbola that has, let's plot these as we do. Excuse me. Okay, find the equation of the hyperbola that has one vertex at 0, 3 and foci at 0, -4 and 0, 4. Once we find the equation, then we will graph the equation. Okay. So first things first, I always start with transverse axis. What is my transverse axis here? Well, all of my important points that they have given me are right here on the y-axis. Next thing, where is the center at? And they don't actually give me the center here. But what I do know is that the center needs to be in the middle of my two foci points. So you can technically use the midpoint formula, or just this is 4 up, this is 4 down. My center has to be right here at the origin. So at 0, 0. So based off of this information here, I know that my formula is y squared over a squared minus x squared over b squared equals 1. So we need to find our a and our b, but let's go ahead and find c as well. Okay, so a is center to vertices, so that's 3. I don't know b, but I do know c is 4. So let's use, and what is it? B squared equals c squared minus a squared to find c. Don't know b squared. Oh, to find b, right? We already have c. So b squared, we don't know. C squared is 16. A squared is 9. So we have b squared is 7. Okay, so now I can find the equation. Y squared over a squared, which is 9, minus x squared over b squared equals 7. So we'll substitute 7 in here. Okay, so there is my equation. So now let's graph it. So to graph it, I do need to find b. We're going to take the square root of both sides. 7 is a prime number though, so this is square root 7. And we've already done square root 7. About 2.6. Okay, so now let's finish this graph. I'm going to put my other vertice on here by going 3 down. And now I need to plot my b to make my box. So from the center, I'm going to go over 2 and roughly a half. So there's my b. And 2 over roughly a half for my b. So connect your b and your v's. And then we will go corner to corner through the center. Corner to corner through the center. And now I can finish my graph. So I'll go from my vertexes and start hugging those asymptotes. So this one's a little bit more narrow of a graph than we had before. Now this one doesn't ask anything about asymptotes, but just for practice. What are the equations of my asymptotes? And we are using y equals plus or minus a over b x. Plus or minus, my a is 3, my b is square root 7x. So if we look at that graph, we are going up 3 and then running 2.6-ish, which was that square root 7. And if you want, I just kind of noticed looking back at this, we never drew in these asymptotes. If it doesn't bother you, you don't need to do it. But we have these asymptotes going on right here, going through the center and then kind of getting close. So if you want to draw those in, since we did it on the first one. Okay. Now somewhere, where did my paper go? Example 5 says write the equation of the hyperbola shown in the graph. So what we need to do first is find out our transverse axis and our center. So what is the transverse axis? Well, if this is opening up and opening down, my transverse axis is my y-axis. And then what is the center? Well, you can see where are those asymptotes crossing. That's going to be that center, and it's at the origin 0, 0. So that tells me that I am using y squared over a squared minus x squared over b squared equals 1. So I need my a and I need my b. Well, from the center to this vertice represents my a. And what is my a? It is not 1, because this is 6. If it was 1, that would be 1, 2, 3. So these are going up by 2. So it's 2, 4, 6. So here, my a equals 2. And then I'll get a different color here. From center to that box gives me my b. This is also going by 2, 4, 6 by 2s. So if this is halfway in between, that tells me that my b is 1. And you can verify that. They tell you the slope. If you use rise over run, we go up 2 and run 1, we have a slope of 2. If we go up 1, or up 2, run a -1, we have a slope of a -2. So you can use those to kind of like help you verify that you've got your A and your B right. So now let's substitute in. We have y squared over a squared. If a is 2, a squared is 4, minus x squared over b squared. B squared's 1. 1 squared's 1, so I'm just going to put minus x squared. But if you want to put that over 1, that's good too. And then equals 1. So there is my equation.